Hi everyone, thanks for joining. We'll get started with demos today and then open topics. Overall, looks like we don't have too many open topics, so yeah, we'll see if this might end like in 30, 45 minutes. But yeah, I'll give it a couple more minutes for everyone to join. Does anyone want to volunteer to take notes?
Sure, probably I can go ahead and do that.
Okay, thank you. I'll resend the meeting notes link in the chat here.
Sure, thanks.
Hey, Sachi, you want me to host it? I know you hosted last time.
Yeah, sure. You can take over. Just wanted to, yeah, welcome to all of our newcomers. And if you'd like to give a brief introduction and any areas of KAITO that you folks are interested in, then we definitely want to, yeah, expand that discussion and have that kind of to start off our calls moving forward.
Yeah, looks like we have Rashak. I'm not sure how you pronounce your name. Is it Rajesh Kush?
Yeah, it's Rudraksh.
Okay. Yeah, well, welcome to the Kaito community call. I know you're new, so why don't you introduce yourself?
Sure. So, hi everyone, I'm Rudraksh. I work as a generative AI engineer in Bangalore in CS. And previously, I contributed to Google Summer of Code with OpenSUSE and have been quite interested about cloud native and AI integration. I met Sachi in KubeCon India in December, so she introduced me to Kaito, and since back then there was no community, like Slack or anything, so I contributed a bit, like some documentation, and now I'm looking forward to contribute more. So this is my very first community call here.
That's awesome. Thanks. And yeah, welcome to the community.
Thank
And yeah,
you.
before we get started, just want to remind everyone to that we're under the CNCF Code of Conduct, so be respectful to everyone. Yeah, that being said, let's get started. And to kick us off, I think we have Sertosh to show us some demos for AI Kit, and we also have Banshee to demo the GPU VRAM estimator. And yeah, we're gonna start with demo first, and then we're gonna go into open topics after. So yeah, I'll give it to you, Sartash.
Thank you. Let me share my screen. I'll need to find the correct tab. I always get very confused about this. Cool. Can everybody see my screen?
Yeah.
Okay, cool. So yeah, I'm going to talk about the AI kit today, which is moved into the KAITO project organization under the CNCF CNCF Sandbox organization. So there's more information about the AI kit integration, specifically about KAITO, in the KAITO documentation, but I want to make sure that I also talk about AI kit as a standalone, so folks are familiar with how it works in general. And then you can find the documentation of AI kit in here. There's like links from the main README to there, but most of the docs are in the website. So AIKit has two components. One of them is very similar to KAITO. One of them is for inference, and then the other one is for fine tuning with Onslaught. And then for inference, AIKit uses local AI as the inferencing engine, which is basically a wrapper for many different backends and inference engines, including VLLM, Llama CPP, there's XLlama, there's like a bunch of them. There's probably like pages of different backends. And then similarly to Kaito, it provides an OpenAI API compatibility, which makes it work really well with Kaito as like a drop-in replacement because it talks the same API. And in addition to what Kaito supports with VLLM, it supports it doesn't require a GPU. You can run this on CPU, including Apple Silicon or Linux ARM 64 based CPU, or it does not require any internet access because by default the models are baked into the images. But you can also take them out if you wanted to or download them. But by default, it doesn't require internet access, so it should work with like in any air gap situations. And then you don't really need any additional tooling. There's no CLI, there's nothing to download except if you have Docker or Podman, that you're basically good to go. The main point of the AI kit is also the minimal image sizing, because we only put in the required components that creates like smaller images. I mean, the models take space, but the runtime is like as small as possible, with less vulnerabilities and smaller attack surface with custom images. And I'm not going to go through all of this, but it also supports the multi-model things. These are things like the vision support, so you can give it a picture and then say, "Hey, what's in this picture?" You can ask questions like that. And then also it supports different backends for generating images. These are things like the Flux, for example, which we'll see a quick demo in a bit. And then I think I walked most of these through it, but you can get more information in here. For any of the demos, they're all pre-recorded and hosted in here. So just so people understand how it works, we'll see, for example, running something with CUDA or running something with ARM64. So if we go with this is like a 46-second thing. So you basically just run a command. These are changed to Kaito project. I have not updated these demos, but so these have my name. But for any of the pre-built images, I'll show you after this. And so you'll be able to find them in the GHCR Kaito project. So this was something that was running on ARM64 architecture. There's also a web UI that you can access by going to the portal, and you can just basically query, and then it'll give you an answer. Let me show you for the and then coming back to the pre-made models. These are like the sort of the presets equivalent um, of KAITO. So these are the ones that I test specifically and then validate as much as possible. Um, and they support both CPU, AMD 64 and ARM 64, and also CUDA by default. So the only difference is GPU's all flag in here. So if you run it with GPU enabled, which means as like the GPU drivers and whatnot to the image, you can basically get CUDA support. In addition to this, if you're on a Mac, an Apple Silicon Mac, if you run this with Podman, this image is slightly different. This is like a special Apple Silicon image. You'll get Apple Silicon, but acceleration through Vulkan for Apple Silicon. So it's not just running on CPU, but it's running on the accelerated bits of Apple Silicon that uses Vulkan. So it's faster on Macs. Yeah, and then only the GGUF models, which are Llama CPP backend, are supported there. And then yeah, these are basically the model gallery preset equivalent of KAITO. I deprecate things as things go. You can find them in here. And then new stuff pops up. And when it's deprecated, it means that I don't update those images. So they might have like an older version of the runtime and whatnot. So they are like as is. And then same thing for the CUDA. So this runs on a GPU machine. Exact same thing. And then you can get a GPU accelerated. And then going back to the demos, yes, similarly, we'll see like an image generation here. I just recorded this one a few weeks ago, maybe, yeah, like 2 weeks ago. So similarly, I'm running this Flux image. This one takes a bit, so you'll see it in here. There's like a prompt you can put on the website to generate. This one got a bit updated, but this is the older version of the website. And then it will generate flux images, which are like very, very photorealistic images. And then it takes a bit to get loaded into the memory, but after that, it's pretty fast. And then you can like go from like here, this one, and then I did another query in here. It will generate something else. So once it's loaded into memory, it's pretty fast. What else? Yeah, so those were just like inference part of it for like running this stuff that's either pre-made, but you can also create things super easy. Let me close these ones out. So yeah, so if you have a model in Hugging Face, you can basically copy paste the link. So in this case, this is a GGUF model, which is a quantized model. I think that was like a medicine fine-tune thing. So all you need to do is basically pass the Hugging Face model parameter into Docker and just provide the AI kits to tell, hey, this is an AI kit image, and it'll create an image. So it'll, depending on the configuration you want, you may want to include like the CUDA libraries, or you may not want to just say, hey, I just want to run this on CPU, so I don't want to take additional space with like CUDA libraries and whatnot. Or you might want to say, hey, I want these two backends, but not this other one. So you can mix and match things. Some of them are not supported at this time for like concurrently, but I'm adding support for more at the same time, so simultaneously. So you'll basically get an answer for like, this is like a random medicine fine-tuned model. You'll be able to get an answer from that. Yeah, and then in addition to Hugging Face, we also support the OCI artifacts, particularly from like the Olama's model gallery. So you can basically just define like any OCI artifacts, so something like that, and then you provide the registry in here, and it will grab stuff from Hugging Face. And then finally, it's HTTPS. So this could be Hugging Face. This could be any sort of URL that we can pull. There are also other configuration bits like the runtime CUDA and runtime Apple Silicon if you want to customize these without creating a spec file. And then going back to the spec file, the spec looks kind of like this. So there's like a syntax thing, which is where it tells Docker that, hey, this is the AI kit front end. And then there are things like the debug or like runtime. Runtime is if you want the CUDA runtimes included or not. And then this is like the name of the bits you're installing, and then this is the source. This is like the Hugging Face URL, or it could be OCI registry and whatnot too. This is like a SHA-256 if you want to validate whatever you're pulling, because sometimes the hashes change for these models as they update. So you may want to look out for, hey, I don't want hash changes. So you can just pin to a specific one so it won't get updated. And then the rest is basically config. There's more details about it in somewhere, but this is basically like the prompt templates, and then you can refer those prompt templates. For more information about the model gallery, these are where they are hosted. So all of them in here. So say, for example, GPT-OSS, all of the prompt templates in here. I am working on, so some models, this is like a new thing, some of the GGUF ones started embedding these prompt templates inside the models. So in the future, this is going to be simplified as much as possible. Just use the embedded prompt templates instead of like defining these prompt templates in here. Or the other option is local AI also has some of these embedded inside the binary. You can also just, if you don't specify anything, it'll use those default prompt templates depending on the model. And then let me see what else. Yeah, the fine tuning is also available. This I will need to verify. I've not looked at this in a while. So for fine tuning, you basically create have to create a builder to be able to fine tune stuff. The spec looks very similar to the inference spec, but it's a little different. This is like the simplest one. So you basically provide the base model, and then you provide the data sets. Hey, I want this Open Hermes to be the data set, and then you want the alpaca, and then you want to say, hey, I want this to be on slot specifically. This is extensible to be designed to be extensible. So if there's another project that we want to fine tune instead of onslaught, it will be easily extensible to add that. Yeah, in this case, so you basically Docker build X build, and then you provide this file. The difference is you provide an output in here. So this does not create an image, but this creates a file in the file system. And then you provide, hey, I want the target onslaught. So this is going to go ahead and add some defaults to the onslaught config, install GP drivers and whatnot if it needs that. So you'll be able to see that. And then finally, it creates a new model based on the base model plus the data set. And after that, you can choose to quantize this model. So this one takes a bit, so I'm going to just skip a bit. So at the end, it basically quantizes the model. And then it kind of comes full circle. You create the inference spec, you provide the GGUF model that we just got from fine tuning, and you can basically start inference from that. So it's kind of like a full, like a feedback loop. Basically, you create something, and then you can use that right away, and then you can fine tune it more and whatnot. Yeah. So and then in the end, you can basically you get a model that you can use for inference. So in this case, I think this was like some noodle dish recipe. So you'll be able to get that with the fine tuning data sets. Yeah, I think there's more documentation in here, but those are the main things. Yeah, and then you can find the specific KAITO integration point in here. This is the KAITO workspace. You can define the the match labels, and then the Kaito any preferred nodes. In this case, this is just like a kind cluster running on a CPU, so you'll be able to get started super easy without any sort of GPUs or anything like that. Cool. Any questions? I cannot see the chat if there are any questions.
There isn't any question in the chat. Yeah, great demo. If I want to run the model in a kind cluster on my Mac, should I use the Apple Silicon one or
So
the
if you want
CPU
to
one?
test the acceleration, then you can use the Apple Silicon one. You don't need, so if you're running on kind, you can't use the Apple Silicon one. If you're running on like a Podman desktop, then you use the Apple Silicon one.
Okay, cool.
So you specifically need to use the Podman, and then you use the Podman desktop. So this is the desktop, the Docker desktop equivalent. And it looks like it like this. And then in this case, you create a GPU enabled Podman builder, I think. I don't know what they call it. And then in after you create that specific GPU enabled one, then you can run with the Apple Silicon acceleration. But since kind cluster just runs on Linux, whatever the host platform is, so it'll use like Linux ARM64 or something like that.
Okay. But what if I have a kind cluster on my Mac?
Yeah, it'll use the because it uses
Oh,
Docker, which
okay.
uses the Linux AMD 64 or Linux ARM64 in this case, VM. So it'll just use that one.
Okay.
So Podman is very specific integration, so you need to enable the GPU enabled runner. I don't know if Kind can use that, but I don't think so. Because Kind is Kubernetes in Docker, so I don't know if it supports Podman.
Okay. Chenkoi has a question. Does the fine-tuning happen during the Docker building phase?
Yes, everything runs in Docker build. So for fine tuning, let me show you the other this one. So fine tuning is basically you just do Docker build X build. So same thing, Docker build basically. And then the only thing is you need to create a new builder that says security insecure. This is due to some limitations of Docker at the time. But Docker added CDI now, so that might be that might resolve that issue. I have an issue open for that, so I'm planning on looking into that at some point. But yeah, this is without CDI, so you need to use the security insecure. And then the main difference is the dash dash output, which outputs a file instead of an image. So it will basically create a model file like this.
Okay, I see. I think this UX is pretty cool and creative.
Yeah, and then you can take this.
Fine tuning during the Docker building.
Yep, yeah. This one was a bit it took a bit to figure out. It's quite novel. So if you search for NVIDIA Docker build, let me see. Do I have this one?
I come up with a question. Usually
Yep.
when we doing the fine tuning, there are extra more dependencies we needed to do the fine tuning. But during the inference, maybe the library is not required.
Yeah, so for fine tuning, so these
It's
are
two,
basically
maybe
the
it's two phase.
oh, sorry, say again.
I think maybe there's two phase. One is for fine tuning, and another phase is to copy the model to the inference image, right?
Oh, they're two separate tasks. So one of them is Docker build. So this is the fine tuning spec.
Uh-huh.
So there's like the base model in here. So this is like a fine tuning spec, right? So it looks different. And then you basically at the end you get a file which is like with ends like a
Yeah.
or something
And you
like that. Yeah.
copy them to
Yeah, then you can in here, for example, instead of
inference.
source being like an HTTPS URL, you can basically just put this. So like a local file system name. and then that's where you set the Docker context. And then
Yes.
it'll just basically copy that file in your local file system instead of pulling from Hugging Face.
Yes. Yes. Okay, I see.
And
And I
then
have another.
go ahead.
I have another question about the OCI artifacts. You see, you say you can pull the OCI artifacts from the Olama repo, right?
Mhm.
Can you what about just let the AI kit build OCI artifacts image from the Hugging Face repo? Because I used to use the Aura's tool to build the artifacts image by myself, just use a simple script. If AI kits can do this for us, it will be nice.
So AI Kit doesn't
Give
really
you,
have sorry, Hugging Face doesn't have a like an OCI registry. I,
I mean, you can download the files from the Hugging Face repo and convert it to the OCI artifacts image. Convert.
I see what you're saying. So basically, just take the like a model from Hugging Face and then just create an OCI artifact.
Yeah, the OCI artifacts local image, and then we can push it to the repo, the image registry.
But doesn't Oras do that like super easily?
Yes, you use some scripts. It's all about the UX. Um,
Oh, I see. I see. I'll take a look at that. That's an interesting thing. I thought Oras was pretty easy to use for that one, but I'll take a look at that. There are other tools also like for a Crane, for example, that might be a better fit, but I'll take a look at that. That's a good idea.
yeah,
And then
it's just
just
all
to
about the UX.
just to like you basically provide like a specific file, say this and this, and then you want to an OCI artifact from these two files.
Yeah.
Gosh, I'll take a look if that's
Yeah. It's not a technical issue. It's just about UX. It's
yeah,
just
yeah. I'll
give
take a
you
look. I thought Oras was
Hugging
easy, but
Face.
yeah, I'll take a look at it.
Okay, thank you.
Yeah, the other thing that I wanted to show this is the NVIDIA. Okay, let me see GitHub. I think I commented on this one, so I cannot find anything. uh,
Sachi, you had a question?
Yeah, I just have a question that's kind of along the same lines as the last one, in that if let's say like a user built their own model, like they trained it and they have the model artifacts in some storage solution, could AI Kit or Auras be used in a similar way to kind of like package that up um and make that portable for like inference deployment, or does it depend on the compatibility with the runtime that's used? I'm assuming for AI Kit it could make that like round robin choice.
sorry, I didn't fully understand the question, Sachi. Can you repeat that?
Sorry. So you had showed how the models can be downloaded from Hugging Face and
Mhm.
then kind of pushed to the registry, and then AI Kit can AI Kit or Auras could do the containerization, I believe. If the model itself is kind of trained in-house by a user and they have the model artifacts in some other storage solution, could they use AI Kit to in the same fashion as a pre-trained open source model and essentially like serve that in the same way? Or are there other considerations um like given that it's a large language model, that can AI Kit also make that round robin decision on the best like inference runtime for it?
Oh, I see what you're saying. Yeah. So technically, yes. So if you define the model, so like any sort of path, right? Like from the internet, in this case, Hugging Face, but
Mhm.
it's any HTTPS URL. You can either specify the runtimes, and then depending on the the type of the model, we might be able to put some sort of like a sort of backend figure out what the format is. We could do it, but right now there's no like specific way to do that. So right now, say you have to know that hey, GGOF uses Llama CPP, or like you could say, hey, I want to do this with VLLM or some other thing. So right now you have to know that whatever the backend you want. But we could extend it, say that, hey, given a model, figure out the best backend for it, and then add the um, uh, whatever backend that's most suitable for that.
Okay, that's good to know. So with the building the model artifacts themselves, let's say, what are like the indicators of the optimal backend?
I think it's a so there are many competing like basic inference engines that kind of do they all do the similar thing. So they could do the like, full precision models, or they could do the like quantized models. It's really up to the case. Like the sometimes like the tokens per second might be higher for some of them because they added some new nice features and whatnot. And then sometimes like you have like other enhancements in the runtimes. It's really hard to say like, hey, this one will be the best.
Okay. Yeah, thanks for
If you
sharing.
have more examples, like more specific ones, hey, here are the users requested this and that, then maybe we can talk about like those specific scenarios.
Gotcha. Okay, I can bring that up next time as a follow-up.
Cool. Oh yeah, and then I wanted to just show this one. This is basically how it works under the hood. This is for the fine tuning. This is pretty novel. I don't think you need this anymore. Like anybody should just use CDI instead of this. But I thought it was pretty cool. So normally you cannot do Docker build and use GPUs. So Docker build does not allow for any sort of GPUs, only Docker run. So in this case, the way it works is you install the NVIDIA drivers inside the Docker build. And then you have to create these MK nod for these NVIDIA device entries in Linux. And then you can run like NVIDIA SMI. I thought this was pretty cool. I was really determined to get this to work. It does work, but it's very, very painful. Oh, and then this must match with the host's driver version. That's another limitation. And I have not looked into CDI, but I think CDI should resolve all this stuff.
All right, cool. Thanks for the demo. Any more questions to start, Harsh?
Thank you.
All right, cool. Thanks. Next up, we have Banshee for the node estimator demo.
You can hear me, right?
Yeah.
Yeah, it's kind of like experimental. So like I will show some conclusion, but if you want to discuss more, like we can do that. So the all the VRAM occupied will be occupied in VRAM will be inference will be like 4 parts. The model like size, the activation storage, the KV cache, and the non-torch of that. So I think if we have a model is already like certain. So and the total like model like size will be a number. So that it will depend on like how many GPUs we have, and we will divide it into each GPUs and activation and KV cache, and the non-torch is more like NCCR or something. So these are some, and in this one like activations and non-torch usage will depend on the version, I think the VRM versions and GPUs. So for example, like in the we are use V1, we have like we have like chunk prefill enabled with the length of 2K, and like the maximum is depends on like I will show some of the like some of the parameters will impact this one, but all the models I have tested, the maximum is 1.6, 1.66 like 7 or something, 6.5. So I will pick it as a 1.7. Like these things are the trick. So for the same A10 GPU, the non-torch we care about like is 2.5, 0.6 and 0.2. So but our discussion like we don't want to support like 9.0 anymore. So I will pick 0.6. 0.6 like it won't depends on the model, so it's all the same. So I will pick this the 0.6. And like estimation is this is D type. I don't know why that one is disappeared. So it's prefill seconds length multiplied. It depends on hidden size and intermediate size, and it's D type. I don't know why D type has disappeared. And like for KV cache, for KV cache, like is KV cache is max token length multiplied by the bytes per token, and bytes per token is this one. So I will calculate I will add it to the, I will add because you know we know like I know like this one is also needed by our in our like controller. I will add this in the validation then. And like and like one of the I'm not sure if they do this in purpose, and we do this like they do this by error. Like in like 9.1 the max token is always smaller than the model itself. Like it depends on the GPU, and max token we only have two options is like 16K and 8K, I think. So if we have a model like DeepSeek is I think it's 128K, so it will not put in this one. It's a part of like VLM code. So I think that's all of them. So I think I will do the PR in two parts. Like the first one is like do the node one. So the node ST calculator will be in the controller, and like the max token will be in the validator. So and it will be supported. I will do that tomorrow. So any other questions for me about this thing and the PR? Qinghui, you can ask me if what else you need from me.
Can you jump to the fifth slice? What's the magic number? 18. No.
It's
Yeah, what's the magic number 18 there?
it's
18 multiply hidden size
it's
and the 4.
I don't know what is this one, and it's just like prompt experimental. So it will be like this, and I can say like it's not like a KV cache. It's KV cache we can calculate it in a very precise way. And in the rough estimation, I think this is quite like rough. I think rough like it's not that exactly. It's only I think it's the best is in Falcon, and but it's not good in
But there are two const variable. How can you come to this experience number 18 and 4?
This one is more like from one of the paper, and I also read some other papers. If you want to see something like here, this is part of my like rural thing. You can see another. This is one of the option like is 3 multiplied by something, but it is even far more like not that good from the real one. So I just like drop this. and there's some other options of how to calculate this, but this is at least this I think the largest difference is 3 times. It's not that large differences. So I will try to, and it is good in some of the models, so I will pick this one. In our real work, I think you have already seen this. I will pick it as a const, and the largest one. I mean, the largest one is about like 6.6 or something. So for the largest one, so it's not the smallest one is smallest one is about like point 0.2. I forgot the exactly number. I can go back to my number. So it's not that big. It's not that big one, and it only depends on model. So if we want to write that in model, it will, I think, very much as like we don't want model dependence a lot. So we only put the model size is enough. We don't want support that like model by model size.
Okay.
Right?
Can you jump to the fifth slide?
Okay.
If the model using the different attention architecture, will the formula be different for different attention architecture like the GQA or MHA? Different attention architecture. I think the formula should be different from the paper.
Yeah. I think attention, we have 2 attention heads, right? One is the attention heads and one is key attention heads. So it will be different, right? So it depends on what is the attention heads will be.
And you will add the configuration on our file.go, right?
You mean
the
attention heads?
Yeah, the attention has number you just place in the model.go file, right?
I won't do that, I think.
But different models, their attention has is different.
Yeah, definitely. But one model, it will be the same. So I think I will try to write the whole like bytes per token in our file.
Okay, no problem. Just explain in the comments.
Yeah. So like it will be like or I think a tensor parallel will be it will not be a constant, it will be a variable. So I will write all the others in the bytes per token like per parallel or something. So I will try to write that as a whole number instead of all these 1, 2, 3, 4, 5 instead of all 5 variables.
Okay, I see. Looking forward to your new estimator.
Okay, cool. Any other questions for this? And
How are you gonna get all the variables like hidden size, number of attention heads?
It's one of it should if you log into the Hugging Face, it will be one of the
Configuration.
Yeah.
From the model repo. You can just show us a configuration file.
Yeah, I see like hidden size, intermediate size, and like hidden layers, like this is hidden layers like kiwi cat, and another head. Yeah, this is attention head, so it will be different. And like the D type is here. The D type is float 16, but you can match that like search like what is the D type number of like B float 16. So like it's more sometimes like key value heads will be the same as the attention heads or something. So we just calculate it as the same. So if they don't like specify some of them, so it will be if they divide by each other, it will be 1. So we will put that as 1. So that's another case. So most of them I mean most of the from here where's the slide? I think all of them are by the if we have the Hugging Face, we will get it. The only parameter I need to test one by one is the model size, because like how the VRM model size is different from the real model size is different. Is different from you calculate by each other, and it will have no. And it's not like we can multiply by something. I can show you if you want to see something, I can show. You can see this one is I calculate the sum of the TensorFlow files, and this one is how the VLM will treat that. We can see most of them are around 90%, but this one is more than 100%. So there's not an option like we can see this one and calculate the second. So the only way is to test it. So that's
Okay.
what is going on. Yeah.
So the config.json file, it follows a strict schema, right? Like every config JSON in every Hugging Face model
Yeah,
will be the same. Okay.
yeah. They will provide this configuration.
Yeah.
And I want to give more context for the audience about this work. The OM issue is the most critical issue when you deploying a large model. This estimator just want to address this issue to give a roughly estimation for the memory cost before you deploy the model on a specific GPU type. It will give you a roughly max model length that you can run on this model plus GPU and GPU count combination. Yeah. Then you can safely start your deployment without any OM issue. Yeah, it will largely improve the user experience with this estimator. Okay.
Yeah. Fei trying to say? Oh, thanks.
Does it depend on what kind of GPU you use?
Which thing you said? I think like we have if we have already I think we have two things, right? One is the model and the other is GPU, right? And another thing is the VLM. Like GPU will impact your like non-torch, will impact your non. I think mostly will impact your non-torch, and VLM version will impact your like activations, I think activations and non-torch. Like the model will impact the activations, non-torch, and model size. So that's how like they will impact each other.
And the non-touch memory bunch you mentioned is that the CUDA driver will try to reserve some memory for the CUDA context. It's different from different GPU type. The memory reserved by the CUDA driver is different for different GPU type.
Yeah, it's mainly I think I saw something else. Like we can think about all the other things despite our like inference, like the AI things, the GPU things, and some like initializing will be considered as non-torch. So that's how we call it.
Okay. Yeah, I just want to point that different GPU type have different non-touch memory. Okay.
I guess one follow-up question I have is if that differs per GPU type, is it still a standard ratio to the total like memory offered by the GPU, or it just kind of varies in a not a repeatable pattern?
You say that it can be repeatable or not?
As in like what to expect in the true available memory versus what is reserved for the driver. Is it like a percentage of the total memory and then that is what is standardized across different GPU sizes?
I think it depends on GPU. I don't think there's a percentage, certainly percentage for it, but in one GPU it's mostly the same. So what we need to test is just deploy one of them and to get the non-torch of it, and it will always be that one. So, but it depends on what's inside it. So, yeah, so it will. I think it's quite small. I think I already show it in the newest like 10.1. What I need to consider, like it will have some like details. I think Tim will also uh, deal with it in by the utilization, but what we need to after the utilization is only 0.2 GB. So I think in total like it's about 2 GB in I think it's more than 20 GB like GPU. I think 20 or 40, I forget the exact number. So it's not that like large for us.
Okay.
Yes, for short conclusion, we'll firstly we'll do some experience on a specific GPU to get the non-touch memory, and we also will give some buffer for the like maybe different CUDA version are different. We will give some buffer for that.
Will this calculator often apply to like just I
Uh,
think
yeah,
NVIDIA
we
GPU.
we uh-huh.
I
Do you
haven't
mean the
had
NVIDIA or AMD GPU? We didn't get any AMD GPU yet.
No, I just want to clarify, like, is this optimization, will it only kick off if we see that it's like an NVIDIA hardware, or what, like, how does it work if it's like a non-NVIDIA one?
I think the four like paths to like to occupy VRAMs will be the same, like the non-torch, the model size, activations, and this will be the same. And I think for the KV cache and the model size, I think that will be all the same, even in the AMD one.
Mm-hmm.
So,
Yeah.
but other two that will be different, I think.
Yeah, the KV cache activation and the model weights are the same for different GPU, I think. It's just in theory the number is calculation in theory. But other things like the CUDA driver reserved memory, they may be different from the AMD or NVIDIA, they may be different. But we didn't get any AMD GPU at this time, so we haven't do any experiment on AMD GPU. Yeah, so it's only NVIDIA plus VLLM for now.
All right, cool. Thanks, Banchi, for the demo. Any questions? Any more questions? Okay. If not, we only have 5 minutes left, so let me open my note. Okay. I have one open topics, but I think it's gotta be a super quick one. I recently opened this issue called Improve EDE Test Duration with Spiegel. So recently I cut a really huge PR to upgrade VLLM to 0.10.1, and I was relying on the EDE test to give me signal of whether the PR is good to merge or not. And I noticed a large chunk of the EDE test durations are spent on pulling the base image. of the base image for the inference runtime. So things like VLM and the Python base image and all the dependencies. That base image is around like 4 to 5 gigs already. And every time we use GPU provisioners to provision a new node, the new node has to pull a fresh copy of the base image from MCR. So that itself already took like 7 to 8 minutes, or sometimes it can be 10 minutes. So recently was looking into a tool called Spiegel, which is sort of in cluster OCI registry. So how it works is you only have to pull an image once, and then if any new nodes that join the cluster wants to pull the same image, instead of pulling it from MCR, it'll pull from the cluster OCI service, which is definitely faster than pulling from MCR. So I just want to let everyone know there's this problem, and I think it'll be great for us. Yeah, it'll be great for us to at least
address
at least make the ED tests to not take like
faster.
2 hours. And I think anywhere like 45 minutes or maybe under 40 minutes, it'll be a huge win. Faith?
So this is for base image only, does it?
I mean, it's for any image. And I mentioned base image because it's the most frequently pulled image during E2E tests. And every time we spin up a new node, it will take like 10 minutes to pull. So
No, but for other tests, for model specific weight file, you just use once. How does this help?
because every time you have a new EDE test, like a EDE test to test models, it has to pull the base image, the KAITO base image that contains the VLLM runtime and all the Python dependencies.
Base image, I definitely get it. I'm saying that the other weight file that we save as OCI manifest.
Oh no, I'm only talking about the base image because
base image is okay. Base image is okay.
It's not gonna
base image is large. It's large.
Yeah.
And for the step 4, I think it doesn't works now because I used to try to increase the parallelism from to a large one. It's mainly because we have a limited quota.
Yeah.
If the parallelism is large, you may consume all of the quota. Yeah, that's the question.
I don't recommend to go more than 3. I think 2, because
2.
Currently, the way that we allocate resources, we try to support 2 parallel E2E. If we got 4, we just cannot do 2 parallel E2E for sure.
Yeah. Makes sense. Okay. Yeah, I have Abhishek started looking into this because I think it's going to be a huge win. Just even if we cut down the end-to-end test duration by like 20%.
Oh, 100%. I love it.
Yeah, definitely. Yeah, thank you.
And yeah, another benefit is just, we can run more end-to-end tests, so we can cache more regressions. So yeah, that's all. And yeah, we're at time, but Sachi, is this added by you?
Yeah, this was just a quick update, but I did want to reiterate Rita's question in the chat. Could KAITO as a whole benefit from Spiegel more generally, like not just in our end-to-end test duration, but for multiple workspaces, let's say like deployed to a single, or KAITO workspaces deployed to a single AKS cluster?
Yeah, I think Spiegel in general is just a great way to pull from remote registry less often, especially like AI ML images. They all use Python based image, and it has huge dependencies. So yeah, I think in general, even especially in the AI ML space where container image are like tens of gigabytes, it's definitely worth having Spiegel in any cluster. I haven't tried it since last time, like a year ago. So I'll probably spend some time retesting this. But from my experience, it definitely speed up the image pulling time in general compared to pulling from like remote registry. But yeah.
Okay, cool. And this may be more of a naive question, but would Spiegel then be deployed with KAITO as part of like the workspace itself, or just kind of like the enablement to begin with?
I think we're gonna start with enabling it in the EDE test alone. I think it's gonna be a separate discussion whether to include it as part of the official KAITO hum release or not.
Yeah.
Yeah. All right. You want to talk about this, Sachi, or you want to leave it to next community meeting?
Yeah, I can leave it to the next one since we likely won't have an update until next week. I think there are a couple more questions in chat if you have viz over what the chat looks like.
Yeah. P2P image accelerations, like which one? Because I think Strigo is probably one of the most popular one that I'm aware of. I know there's
It is
PRD,
the one called the Dragonfly.
Dragonfly.
Yeah, it's
No,
it's also a
never heard.
P2P.
Okay.
It's one of the first CNCF sandbox project from in the CNCF.
So P2P in this case won't help in general. So based on the experiments we have done, so Ganesh has a Kubitan talk about the P2P user Spiegel. The finding is, unless you have a seed node with about 32 nodes, you won't see too much differences. So, but in this particular case, I think the idea is not P2P. The general idea is we have a local registry. You don't have to go through MCR.
Yeah, that's correct. Yeah, I can also take a look at Dragonfly. But yeah, I'll have Abhishek lead this work where, you know.
I think PRD may be more relevant, but okay.
Okay, yeah, okay.
Okay, I will take a look at the speed.
Yeah. Radarsh, you have a hand up. You have your hand up.
Yeah, I wanted to discuss about the open topics. The GK, like KAITO pipeline setup on GK. So, is there is KAITO currently supports like with any cloud provider? I think there is only documentation required for this GK setup, right? Or do we need to implement any feature? I have my GK cluster up, so I can probably start tweaking around with it. Or is there any development work going around for the GK thing?
Yeah, great question. So KAITO works on any cloud, but it is optimized in a way that we have no provisioning steps to before we deploy the actual inference service. So how it works is for Azure and EKS or AKS and EKS, we use Carpenter to provision the nodes on behalf of the users before we actually spin up the deployment, the inference deployment. But there's also ways to disable the no provisioning part. So it's really up to you whether you want to have no provisioning as part of your KAITO workspace creation steps, right? So my question is, do you already have GPU nodes in your GKE cluster?
Not yet, but I can set that up. I have some, decent amount of credits that I recently won from hackathons, so probably I can set up which Yep.
Okay. Yeah, if you have your own GPU node, there are ways to have your KAITO workspace select them through label selectors. I can give you the documentations in the chat.
Sure, thanks.
Cool. And yeah, we're also looking into having GKE or GCP node skew as part of KAITO's node provisioning steps. So in addition to AKS and EKS, we're also looking into integrating that to GKE.
Yep, sure. Thanks for briefing down on it. I'll continue more on Slack as I progress with it. Thank you.
Cool.
Yeah,
Awesome.
great. Thanks for volunteering. And if it helps, I can create like a work item within the GitHub project and assign it to you. And then yeah, we can continue to like answer open questions or just discuss that work stream in Slack.
That would be awesome, Sanjay. Yep. Thank you. Looking forward to it.
All right, cool. Yeah, thanks everyone, and I'll see you all next community meeting next Tuesday. Cool.
Thank you.
Thank you.